Hi, my name is Pedro Camargo, and today it's my pleasure to talk about AequilibraE, an open source package for transportation modeling. So what's AequilibraE? AequilibraE, it's a Python open source transportation modeling package. And that means three things. The first one is that it's a Python 3 package. The second is that it also has a QGIS plugin that works in any version of QGIS 3.8 and up. And the third thing is that it has between 2,000 and 3,000 hours of work put in it so far. So open source, free to use, but quite expensive to develop. Why it's needed? Three main reasons. First one, for research, which is what suggested or prompted its initial development. Second one is for NGO and advocacy work, so cases where full transparency is a key requirement. That might become an issue in government work in many countries, and it seems to be the case. And the third reason is for use in developing countries, where the cost of software alone is prohibitive and often means these models are abandoned after all your funding agencies leave the project, because local agencies cannot even afford the maintenance of commercial software. So what are its main features? First, there's a model file that really addresses network editing like no other solution outside modeling software has been able to do so far. And it's everything done through database triggers and in a Spatialite SQLite file. Which means that everything that you want to do in terms of network editing can be done in any platform, in any way that supports SQLite, Spatialite, be that straight into as with SQL queries or with any GIS software. Then in the Python package, you have a series of really basic transportation modeling features, just like traffic assignment, synthetic gravity models, import networks from OpenStreetMaps, matrix manipulations, a general path computation engine, so on and so forth. And there's a third layer of features that are in the QGIS plugin, and are really those that are related to the GIS portion of transportation, like desired Delaunay lines, making flow maps, preparing networks, editing networks. The QGIS plugin also gives you access to many of the features that are in the Python package, but it is not comprehensive or fully comprehensive. So the model file. First, it handles very large networks. Say, for example, the entire UK network or the entire India network is not difficult to handle. Because it's SQLite, Spatialite, it is can be added programmatically. And as I mentioned, supports editing in any GIS software that supports Spatialite. And everything that is underneath, under the hood, it's really easily translatable to PostGIS. Most queries without even adjusting the SQL dialect. So, and in that scenario, you can basically have teams of multiple analysts editing networks at the same time, be that at a local with a local PostGIS deployment or something in the cloud, whatever you want to use. So here I have the model for Malta with the links and nodes, open QGIS on the left, and on the right the project database. The project database has a few tables just for documentation, like the about table and the attributes documentation, which is very useful when you're dealing with the API. And the links and nodes table, of course, and two other important tables: link types. So each link must have a link type. Modes are the modes you specified in the parameters when downloading, and each link will have a set of modes identified by a string of concatenation of all link types, of all mode types, and a single link type. Nodes, the nodes, in the other hand, will have strings for modes and link types for all the links that are connected to that node. These values are updated automatically, just like the A node and B node of each link are updated automatically as you move links around and you change link positions. I'm gonna try to delete the nodes, all these nodes here. As soon as I try to delete the nodes, I'll delete the nodes. Yeah, deleted. I'm gonna, yeah, they went away. I'll try to save. Well, you can't. I tried to delete 99 nodes, so this error plus 98 because, well, it turns out you can't delete a node if a link is using that node. So I'll discard, the nodes are back. But on the other hand, if I delete the links, why not? And I delete the links. When I save, the nodes are gone as well. Let's say, for example, this link is poorly drawn. What I want is to get this link here. No, I'm sorry. This is the tool. I'm going to get this link and connect there. You see that it's this link, before I save, this link is going from A node, B node is going from 2111 to 31830. As soon as I save this, that node went away. It's no longer needed. And the B node information on this link got updated to 32328, which is the ID of that node there. So now that we have seen how network editing can be done, and in that case in QGIS, let's go to the Python package and let's jump straight into traffic assignment, which is probably the topic that most people are interested in. First of all, it was built on top of other open source software. So I borrowed the original Dijkstra from SciPy, which was single-threaded in that case, and multi-threaded in our all or nothing. Then there are four equilibration algorithms that were implemented in AequilibraE. The method of successive averages and Frank-Wolf, mostly for historical reasons, and backwards compatibility, comparison with other software, conjugate Frank-Wolf and biconjugate Frank-Wolf. All of these algorithms supporting multi-class traffic assignment. So we did some benchmarking using the Chicago Regional Network, which is available online for research. It's a network with 39,000 links, almost 13,000 nodes, and roughly 1,800 zones, which is big enough for in the order of magnitude of real-world networks. If we see the results of the chart in the left bottom corner, you're going to see that the results of the link flows after 500 iterations are really, really close to the link flows or the best known solution for these link flows, which were converged to something to the order 10 to the minus 14 or something of that sort using an origin-based algorithm. To the right, you have this convergence chart that really shows how convergence improves moving from MSA to Frank-Wolf to conjugate Frank-Wolf and then biconjugate Frank-Wolf. All these tests were run in a 6-core, 12-thread, reasonably new laptop with at less than 3 seconds per iteration. So another topic that people are really interested in when they look into AequilibraE is use it as a engine for really large-scale path computation. So if you imagine the whole of United Kingdom example as imported from OpenStreetMaps, a one-to-wall distance between any 2 points would take roughly 5 seconds in the same laptop I mentioned before. But a 100 by 100 skin matrix would take around 100 seconds, so roughly a second per origin, really showing that you can leverage multi-threaded pretty well. So other Python features that we don't have time to get to today are the sub-second distribution model, so Fratar furnace application and synthetic gravity model calibration application, flexible OpenStreetMap network downloader that allowed me to download networks for all countries or virtually all countries on Earth in a really short amount of time. And there's also full integration with the NumPy ecosystem. So now on the GIS side or on the QGIS side, you can do desire lines. These are the yellow cab trips available from New York, for New York. There's also available Delaunay lines, which is a different take on it, which is basically developing a network from a Delaunay triangulation and doing all or nothing assignment of those trips using that network, and really gives you a much better view of the data, showing that Newark, for example, on the left of the map, really doesn't have that many trips to Manhattan by yellow cabs when compared to LaGuardia and JFK, which is really not clear in the Zaire line. So it's a nice map to have, and it's really quick to be prepared. There are other GIS niceties, as I call them, so you can do multi-class flow maps, scenario comparisons. In that case, gray is all the common flow between one scenario and another. Green is what is positive, what is extra in one scenario. Whatever would be negative would be decrease would be red, and all that in an environment that is very much GUI driven. So all the documentation is a lot more visual. So video tutorials, print screens of the interfaces, and a lot more driven, or a lot more really targeting non-programmers. So finally, AequilibraE is more than the algorithms and the process. We're really trying to do professional software development. So everything covered by a multitude of unit tests with coverage analysis, linting to keep the code clean and legible, thorough documentation using industry standards, and really focusing on DevOps, which is really this set of practices that allows us to develop and deliver software in a organized and professional manner. And with that, I think that's all I had for you today. Would like to thank you for watching this presentation, and I'm looking forward to all your questions, and thanks for your interest on AequilibraE. Have a good day.